Hey, what's up guys? In this video, I'm going to show you how to find the chi-square statistic from a two-way table, and I'm going to also show you guys how to find the p-value using a graphing calculator TI-84. So I have a two-way table here, and one of the questions that we can answer is, does background music influence what customers buy using this data here? So the two-way table has different categorical variables. We do have the entry order by a customer, so we have French entries, Italian, other, and we also have the type of music that the restaurant plays while the people are eating in the restaurant. So the music, well, we have none for one category. We have French music and Italian music. So what we're trying to answer is, well, does the music played in that restaurant influence what the customer is going to buy? So if they play French music, will they buy French food? Or Italian, will they buy Italian food? Or if they don't play music, will they buy other kind of food in that restaurant? So when we use a chi-square test, we are trying to see if there's a difference between the categorical variables. And remember that we are comparing categorical, not quantitative. So that's why we use a chi-square test. So same as the other tests, we do need a null hypothesis and alternate hypothesis, and then we can find the chi-square statistic and the p-value. So I do have a null hypothesis, and for a chi-square test, we say there is no difference in the true distribution of entries ordered at this restaurant when no music, French accordion music, or Italian string music is played. So we're saying that there's no difference in this restaurant. For the alternative hypothesis, well, we say there is a difference in the true distribution of entries ordered at this restaurant when no music, French accordion music or Italian string music is played. So again, the alternative hypothesis, we're saying there is a difference. We're not saying which one is different, but we're saying that there is a difference in that distribution. So for a two-way table, you can input that two-way table in your graphing calculator, but we are going to use the function for matrices. So we are going to make a matrix, and using a matrix, we are going to use the chi-square test. So in your graphing calculator, you are going to make a matrix using the function for matrices like I mentioned. But when you look at the two-way table, you guys are going to just put the data from the body of the table. Sometimes they do give you guys the marginal distribution. So here I did circle the totals for the marginal distribution. So we have the total of music down on the bottom, and we have the total of entries on the side. You guys do not put those numbers in your matrix. You just need the body of the matrix in your calculator. So you guys will go to your second, and you press this button that has an X to the negative first power. But in blue, it will say matrix. I know it's a little bit hard to read, but it says matrix there. So once you guys go there to second matrix, you guys have options, and you guys will have to put the numbers, or you guys need to build a matrix in the calculator. So we do have the names of the matrices. The calculator uses just letters. You guys have variables, and they are capital letters A, B, C, D, E, F, G, and it keeps going to a few more. We have some functions or some operations we can deal with matrices, but we don't have to worry about that in AP statistics. What we need to do is we need to edit the matrix. So I do have two matrices. Notice that I have two different matrices, and those numbers, 3 times 3, is not that you're multiplying, but that is the size of the matrix. So I'm going to go to matrix A. So I'm going to press enter for that one there. And here you see that we have a cell or a table with different cells, and we have 3 rows and 3 columns. That's why this is a 3 by 3. We have 3 rows and 3 columns. If you guys have 2 rows, it will be a 2 by 3. And if you guys have 1 column, it will be, let's say, 3 rows and 1 column, 3 by 1. So this here, and you can change it. You can change it 2 by 4. So we have 2 rows and 4 columns. You don't see the fourth one, but the fourth column is here. We can change the size to a 2 by 2. So it just depends what is the size of the matrix. But right now we have a 3 by 3. So I put that there. Notice the calculator gives me the 3 rows and 3 columns. And I need to put the numbers in. Now the order is very important. When you guys put the numbers in your matrix, it has to be the exact order. So make sure that you guys have those numbers in the exact order in the calculator. So I do have the 30, I have the 39. I'm going to put the 30, which is the next number, 11, the 1, the 19, and I'm just looking at the table right now. 47, 35, sorry, 43, it's not 47. It's 43 and then 35 and then 35 again. So you can double check the numbers in your matrix. 30, 39, 30, 11, 1, 19, 43, 35, and 35. So you're not using the marginal distribution, you're just using the body of the matrix or the two-way table. Once you have the matrix, so this matrix is stored in matrix A. So you have to remember, these are your observed counts. So from the data, we got these numbers from the survey. So the next step is you are going to do the chi-square test. So we go to the test function, test, we go to the right side, and we go down all the way to chi-square test. Now remember that we do have two types of chi-square test. We have the regular chi-square test, and the second one is chi-square GOF, which is goodness of fit. So the chi-square test is when you have multiple categories and you are comparing different categories, like using a two-way table. So we're going to use this one, x squared or chi-square test, and we need to say where are the observed counts. So I do have matrix A here, and the expected counts, the calculator will find those expected counts for us. So we need to say where do we want our matrix for the expected counts be. So I want the matrix to be in matrix B. So we're going to calculate. Now, let's say that you want to change the names of those matrices. Well, when you guys go here, observe, and you see the cursor blinking, you can go back to second matrix, and you choose a name you want to use. So under names, I want to choose one that I need to use. So I know that in matrix A, that's where my observed counts. But if, let's say you use matrix C, you just go down to C, and that's going to change that to matrix C. So you go to second matrix, I'm going to change it back to matrix A, because that's where my data is at. So I have matrix A. I want the expected count to be stored in matrix B, that's fine. And I'm going to calculate. So I go to chi-square test, and my chi-square statistic is 18.2. Let's round that to hundreds, 28. And my p-value is 0.00108. I'm just going to say 1. So let me write those down on the paper. So my chi-square statistic is 18.28, and my p-value equals 0.0011. You can round to 4 decimal places, because remember, p-value is a percent or a probability, which you can turn into a percentage. So this one you can say is 0.11%. If you move the decimal to the right, 0.11%. Now let me show you guys something else with the calculator. So you have your observed counts. What about if you want to check your expected counts? Well, you guys can do a couple things. You can go to, I'm going to quit here, second quit, so I can erase everything. You can go to second matrix, and under the names, you go to matrix B. So that one right there, you choose that matrix, you hit enter, and it's going to see on the screen, it's going to show the matrix B, and I'm going to hit enter again, and it's going to come out with the values from the expected counts. So the first one is the expected count is 34.22. So going back to the table, when we look at no music, none, and French entry, the observed was 30, but it was expected 34.2222. And the next one, the bottom one, no music, Italian entry, well, observed was 11, but expected was 10.71. 0.16, and so forth. So that's one option you can do. Now notice that to see the other numbers, there's more. You go to the right, press right, and you can see the rest of the numbers. Now this works really well, but I don't like this because when I go to the right, sometimes it's kind of hard to differentiate the numbers. So there's another option you guys can use to see the expected counts. So I'm going to go second quit so I can erase or clear everything. And I'm going to go back to second matrix and I'm going to go to edit. Okay, I'm not going to change anything, but let's say I want to edit matrix B. So I choose B, and here it has the expected counts. Now notice this is more organized. They don't give you a lot of decimals. They give you guys 3 decimals, which is fine for the expected counts. You don't need a lot. And you can see all the values, the expected counts at once. So this is just another way. Just be careful not to change anything so the numbers won't change. So my expected counts for the table are this here. So if you guys want to compare, we can see Italian and let's say French. So Italian music and French entry. So when Italian music was playing, how many people ordered French? 30 people. What was expected is right here, 34.22. So it's a little bit less than expected. Okay, so we observe we got 30 people actually order French, but it was expected to be 34. So that's how you find the matrix. And again, to do the chi-squared, go to stats, test, and you go down to chi-squared test. Observe, you need to know where are your observed counts, the matrix, where do you want your expected counts, and then you calculate. Degrees of freedom is 4. It's very important that you also write that down in your response when you guys are carrying out a chi-square test. So I'm going to write it down on my paper. I didn't do that, but I'll do that right now. So degrees of freedom equals 4. When you guys are looking for the degrees of freedom by hand without a calculator, remember that you guys get row minus 1 times column minus 1. So you multiply. So there's 3 rows, subtract 1, that's 2. There's 3 columns, subtract 1, that's 2. And 2 times 2 is 4. That will be your degrees of freedom. And with this p-value, since it is less than 5%, remember that you can turn this into a percentage. I'll do that right now. It's 0.11%. Well, we can reject the null hypothesis at significance level of 5%. And also even at 1%, if the significance level is alpha is 1% or 0.01, then you can also reject this this with the p-value. You can reject the null hypothesis because it is less than 1%. All right, guys, so make sure you guys practice using the calculator. You guys need to know how to use many tests on the calculator, so it's very important that you guys practice. I hope you guys like my videos. If you like them, you guys can click that like button and you can subscribe to my channel at any time. And make sure you guys do the work. Make sure you guys use your calculator to practice. And I'll see you guys later.